multimedia players. So moving on to the next topic in the agenda, which is integration of hardware codecs. In this particular section, I'll present 3 different approaches by which, depending upon the architecture, an application developer can leverage hardware codec capability. So the first use case that I have listed over here is, let's take an example that there's a platform which has hardware codecs inbuilt. So how an application programmer will be able to use those hardware codecs? The application programmer would want to use those hardware codecs so that it can leverage the it can leverage those dedicated hardware decoders. The CPU usage goes low, better performance is experienced. So what could be a typical implementation approach? Traditionally, FFmpeg comprises of software decoder libraries. So hardware codec APIs needs to be integrated into FFmpeg framework. Once these APIs are integrated into FFmpeg framework, the applications which are making use of FFmpeg libraries will be able to use the hardware codec instead of software codec, and in turn they'll be able to make use of underlying hardware. So what are the advantages that a developer would get? All the decoding work will be offloaded to hardware codecs. So this will save a lot of CPU bandwidth. So this CPU bandwidth can be used for some other purpose. The next example is playback using libv and FFmpeg. So video acceleration API or libv, it is basically a library and an API specification from Intel, and with this one can enable and provide access to graphics hardware, or what we commonly call as GPU. So in the earlier example, the platform which the user had hardware codecs implemented. Now in this particular platform, the user has a graphics GPU. So the implementation approach will be like, instead of hardware codecs, now FFmpeg can be integrated with VA API, and the VA API will communicate with the VA hardware drivers, and by using VA hardware drivers, it can use the GPU for decoding and encoding. A very good example of how VA API is being used is XBMC. The XBMC player can be configured to use OpenGL ES, and the OpenGL ES is integrated with VA API for embedded platforms. So in this way, FFmpeg can make use of VA API to leverage hardware capabilities. So what are the advantages that one would get by using this particular approach? So this will provide application and access to hardware video decode engine, resulting in enhanced user experience and greater CPU bandwidth. As the decoding work is now being handled by GPU, so again the CPU utilization goes low. The third example here is playback using GStreamer and FFmpeg plugin. As I said earlier in the presentation in this webinar, that GStreamer is the other multimedia framework which is very popular. Now let's say there's a use case that the multimedia player like Totem Movie Player or Rhythm Box is GStreamer based. So it is running on a platform which has hardware codecs. Now it want to leverage those hardware codecs. So one way of doing it is we can integrate those hardware codec APIs into FFmpeg, and then FFmpeg can be integrated into GStreamer as a plugin. In that regard, GStreamer is very flexible. It gives a plugin architecture. So by doing this, it enables the application to make use of hardware decoders. So with this approach, the players which are based on GStreamer would also be able to leverage the hardware capability. So moving on to the next slide. So here I have listed down what are the most common issues which developers face while doing integration of hardware codecs into FFmpeg. So usually hardware resources are not available. The target platform will only have specific kind of hardware codecs. Now let's take an example. If a user wants to play a content which is based on a codec which is not supported by that particular platform. So in spite of you integrated hardware APIs into FFmpeg, user will not be able to see the content. So there has to be certain kind of a mechanism needs to be implemented into FFmpeg, where FFmpeg checks whether that particular hardware codec is available or not. In case that particular hardware codec is not available, then there should be a provision of software fallback, as most of the software codecs are supported by FFmpeg. So by doing so, multimedia application would be able to play a content using software codecs, but the performance will be degraded. So that is the consequence of using the hardware codec. Another scenario could be that a user wants to do a playback and a transcoding simultaneously. But in that particular scenario, the hardware resources are limited. We cannot open multiple instances of a hardware codec. So in that case also, there should be a mechanism where FFmpeg does a fallback to software codec. So by doing these kind of techniques, there will not be any error. So it will be a robust system, and a user can be informed that FFmpeg is using software codec, so the performance will be slow. Another example of what kind of issues developers usually face is like architectural differences. In a typical Linux kind of environment, device drivers of hardware codec are in kernel space, whereas FFmpeg library is in user space, and the plugin which a developer will write will also be there in the user space. So there will be constraints when the decoded data is copied from kernel space to user space, and in case of an encoder, the YUV data is copied from the encoder plugin to hardware encoder. The YUV data is raw data, so in comparison to compressed data, this data is huge in size. So a lot of CPU utilization goes in this copying. So this affects the performance. A user might face audio video sync issues due to these kind of architectural issues. So a developer should be careful while designing their solution. So now I'll present few live case studies where by using hardware codecs it resulted in better CPU performance as well as better frame rate. So the first example is, the user is trying to do a transcode using software libraries. libx264 is a software H.264 library. So as you can see, the frame per second is as low as 8. So this will take a lot of time to transcode a 1080p file. So moving on to the next slide. In comparison, when a user tries to do a transcode using hardware codecs, so the same multimedia content, for same multimedia content, the frame per second is as high as 51. So this gives you a comparison of how much the performance has improved by using hardware codecs. Let's take another example. So in this particular example, I'm trying to do a playback using a multimedia application called as mPlayer. So when I try to do a playback without using hardware acceleration, the CPU usage goes as high as 99%. So in this particular scenario, you cannot perform any other job as CPU is totally consumed while doing a playback. Now let's look at a comparative study where mPlayer uses VA API. So in this particular example, the CPU utilization is as low as 10%. So this gives a comparative study of what would be the CPU usage typically if you use hardware acceleration by the API. Now let's look at another example. In this example, I'm playing again a 1080p content using XBMC, and this is without hardware acceleration. So in this particular content, the CPU usage is as high as 95%. Whereas if I play the same content using hardware acceleration, the CPU usage goes low to around 30%. So this is the kind of advantage a user will get by enabling the hardware decoders and hardware acceleration. Another example is, so here it gives a command line statistics of the performance. So here you can see the video codec usage is as low as 26% and the audio codec is just 1.4%. So in this, the CPU usage is again changed